Hello everyone, welcome once again to another machine learning related tutorial by Team Slidescope. In this particular tutorial, we are learning about how to classify messages as a spam or not. So whether a SMS or a email is a spam or not, we will do it with the help of naive Bayes classifier. We will use Pandas library to read the dataset, which has close to 5,000 entries. These entries are either ham or spam. That means they are either good messages or spam messages. You will learn how to create train test split. You will learn how to use feature extraction, vectorization. You will also see. So here we have given two examples, and then after running it, our model is predicting the first message is 0, that is it's not a spam, and second message where someone is offering to win a brand new iPhone by just clicking a lucky draw link, so can be a spam one. So this is all you will learn and how to find out the model is score from this. So let's get started. So the data set that we are going to use in this project is SMS Spam Collection Dataset from UCI repository. You can download the zip file from here. The SMS Spam Collection is a public set of SMS labeled messages that have been collected for mobile phone spam research. When you will download the CSV file, you will get a file like this. I will provide a link from where you can directly download this file, because in the file that you will download from UCI repository, you need to do some data cleaning. Now after doing this, uh, once we have the CSV file, we will open Google Colab, and in Google Colab you can write SMS spam collection or spam analysis. So SMS spam or not classification using machine learning. So this is what we will do in this project. So the algorithm that we will use in this project is called naive Bayes classifier, and the data set I have already introduced you, which we will use here. You can learn data science and machine learning at Slidescope. We also have a dedicated course on Udemy. If you want, I will provide you the link as well. So we will import pandas as PD, because first we have to load the data set here, and then using this particular folder we will upload our file. So using upload to session storage. Suppose you will come back later to do further analysis in the same project, then in that case also you have to upload it once again. So from here we will upload the CSV file. Once it is uploaded, you will copy the path and you will write df is equal to pd dot read underscore csv, and here you will copy the entire path and just write df dot head to print the top 5 rows of the CSV file. So you can see category is given as either ham or spam. So in the context of email and text message classification, ham refers to legitimate and desired message, while spam signifies unsolicited and potentially harmful content. Now we can do one simple thing, df dot category dot value underscore counts. So this will give us an idea of how many ham messages are there and how many spam messages are there. Okay, so in the example that we have, around 4,800 are ham, which is good, and 747 are spam, unwanted messages. Now let's move further. We will create another column called spam. From df category we will apply lambda. So in lambda function x1 we will write 1 if x is spam. So basically if the category is spam, we will say we will write 1 as the output, and if it is not spam we will write 0. And when you will write df dot head, now you will see wherever the message is not a spam, so 0 is written, and if the message is labeled as a spam, it is 1. So this is how supervised uh, learning works. You have some context, you have information what is spam and what is not a spam, and on the basis of that you can create a model. Now for the data set, we will import for model selection, we will import sklearn.model selection. We will import train test split. This is basically used to split the data set into training and testing parts. So we use xtrain, xtest, ytrain, ytest, and we use the method train test split or class train test split to create these four data frames, out of which xtrain and xtest are data frames and ytrain and ytest are outputs. Basically the messages that we have, okay, we are using df.messages as our x value and df.spam as our y value. So you can also write something like x is equal to, and you can write df.messages as your x value and y as spam, or we can do it directly also. So here, because we have only two important, we will just do it directly, and this will create x train and y train for us. If you will see x train, so you will see we have 4179 rows in x train. So these many rows are given into training, and if you will write x test, so you will see 1393 rows are given into testing. If you want, you can also write something like train size is equal to zero point 0.8 or test size is equal to zero point 0.2. So this way what will happen, randomly it will select 80% of the data set for training and rest of the 20% data set for testing. We can write 70/30, you can take 60/40, whatever you prefer. Now from sklearn.feature extraction, we will use text, and we will import count vectorizer. So count vectorizer convert a collection of text document to a matrix of token counts. This implementation produces a sparse representation of the counts using scipy sparse.csr matrix. If you do not provide an priority dictionary and you do not use an analyzer that does some kind of feature selection, then a number of features will be equal to the vocabulary size found by analyzing the data. So what this is doing count vectorization. That's why we are creating v is equal to count vectorizer. Then x train count will be v dot fit transform x train dot values. So what are the number of training counts, right? Then we will convert the x train count to array, and then we will select two of them. So from 0 to 2, we will select, see how they are appearing. So here is a explanation of this code. Okay, from sklearn.feature extraction.text import this. This imports the count vectorizer class from scikit-learn, a tool that converts text data into matrix of token or word counts. This is part of bag of words model, a common method in text processing where each word in the text is treated as a feature. So each word hello, which is site to download, will be treated as a feature. V is equal to count vectorizer. This creates an instance of the count vectorizer. By default, it will convert all text to lowercase tokenized. That means it split the text into words. So whatever words we have as are registered. So all these text, all these will be converted into words, tokenized, and remove punctuations if any, and build a vocabulary of all words seen in the training data. X is equal to train count this particular line. Fit transform does two things. Fit, learn the vocabulary from the X train, that means identify all unique words, and transform each message into a vector of word counts. Then xtrain.values ensures the raw data or raw text is passed as a numpy array if X train is pandas series or data frame. Then we have X train count to array. X train count is a sparse metric to save memory. To array converts it into dense numpy array, returns the count vector of the first two messages. So let's see an example output. Let's say the vocabulary consists of go, win, free. So then it will be go, win, free up, go, win a free ticket, right? 111, free ticket 001, something like that. So this will be the example output of this. Now we will use naive Bayes. So from sklearn.naive Bayes, we will use multinomial naive Bayes classifier for multinomial models. The multinomial naive Bayes classifier is suitable for classification with discrete features like word count for text classification. So this is very good. Now we will create an object of the class, and then in the model we will fit the X train count and Y train. So basically, usually in previous examples we do X train and Y train, but here because we are doing text classification, so we will write X train count, because here we have fit transform X train values. So it learns the vocabulary from the X train, right? So after doing this, let's see. So now model is trained. Let's say we have two messages. One is don't forget to bring your notes for the group study session today, and the second message is win a brand new iPhone now, click here to get lucky draw, etc. So we can create it as a list. Okay, so we can write down these two messages inside a list. So let's just write it like this. So let's say these are our emails or messages that we have to classify, like which one of them is a spam, which one of them is not. So we know that the first message, don't forget to bring your notes for the group study session, this is not a spam, but second one looks fishy. So our model is now taught. So we will write emails count will be v dot transform emails. Okay, so it will transform the emails and model will predict email counts. So when we will do it like this, it is saying array 01. Remember what we said, 1 is spam and 0 is not a spam, right? So you can now clearly see that our model is now predicting the first message, which is not a spam, as not a spam, and the second message as a spam. So let's add something here. Don't forget to bring your credit card with CVV. Let's see. So again, it is not putting that, but yeah. And the reason for that, because it's an old data set, we may not have information about credit card CVV. But what you can do is you can add some messages which are suspicious as a training data. So this is a simple way of telling whether it is a spam or not. Let me just yeah. Now based on our output, let's find out the X test count is equal to v dot transform X test, the testing data, and model dot score for test count and Y test. Like we know that how from real message that are given, which are spam or not spam. Let's see how many of them is our model able to predict. So you can see it is 99.28, like approximately 100% accurate. Now what you can do is, as a project, you can go to your email and you can create a simple CSV file, copy some emails that you have in your spam folder here and mark them as spam, and some emails that you have in your some initial part of your emails, initial text of your email as ham, and you can maybe load 10 or 12 of them. After following all these steps, okay, you just come here and you load your own data set, or you can write those emails as, and you can train your model with those emails as well, as we have done here. Or what you can do, you can copy 5 or 6 different messages and see how accurately is the model predicting the output. So this was a very simple explanation of naive Bayes classifier in action. In another part we will come with more examples. Please subscribe to our channel so that we can bring more interesting data science videos for you. Thanks for watching. Have a nice day.